it's okay with you, if the recording turns out, are you okay if I post this on YouTube? Is that, no, you don't want it?
Get back to you.
Okay. Yeah, let me know if you have any issues. I can always edit out the teams that don't want to be shared. Otherwise, the implication is you're proud of your work, or the inference is you're proud of your work and you want to share it with the world. It's not unusual for students to come back to me months after a course like this and say, I'm interviewing with AbbVie because of the project plan that we put together in your class, and I used it in the interview, or I used it as a motivation to apply. So don't be surprised if your career, if you're interested, right, takes you in this direction. So with that, we're going to go in the same sequence I posted this morning: Fayetteville, Citadel, Google, Council Bluffs, and Quantum Loophole. So that's 4 teams, 7 minutes each, with a few minutes for Q&A in between. I will let you guys share your screen. Why don't we start with Fayetteville first?
Yeah,
Is
I'll
that
show
you,
my
Anthony?
screen. Yeah. Okay. Can you see this?
We can see it. Let me increase the volume here a little bit.
We can't see it on, like,
Oh, because I'm not pushing the right button. There you go. Does it look all right? Okay, Fayetteville, Fiona, Anthony, take it away.
All right, yeah, so we looked into the QTS Fayetteville data center. So we're going to go over our project overview and scope, our resource and schedule analysis, our risk analysis, and our financial analysis and go, no-go decision. Oh, why is it not letting me go to the next slide?
Click.
I am. Oh, there we go. Thank you. Anyway, so a brief overview. Our data center is located in Fayetteville, Georgia. They purchased 625 acres of land to build 7 million square feet of buildings. So this is definitely one of the largest data centers that's going to be in existence, with a power capacity of 500 megawatts. And they intend to invest $1 billion and finish it by 2032. So for the scope, in terms of land requirements, we need to level it, and then we need plumbing systems and a secured power system. For the building requirements, we need a general foundation as well as specific walls and floors, including an access floor system. And on the energy side, we'll have on-site solar, off-site wind, renewable energy credits, and energy from the grid. And we also need a lot of permits. So some of these include building permits, fire and safety, stormwater management permits, among others. And then equipment requirements will have a fire protection system, mechanical and electrical systems, as well as security systems.
Now to talk a little bit about the resource and analysis. This is going to highlight some of the main values and data points that we got from Microsoft project, including the human and physical resource analysis, the primary project tasks, and then the Gantt chart and our critical path. So as far as the breakdown for the resources go, 94% of the total budget is going to come from those physical resources, including energy, land, building, and equipment. The next section is going to be for the permits that were highlighted. All of those are necessary to ensure that the data center and then run after its completion. That's going to be 5.3% of the total budget. And then 0.3% of the cost is going to come from those human resources, including 67 occupations and over 200 jobs. And the total cost for the resources is going to be $1.8 billion, which is $838 million over the intended investment of $1 billion. And then to kind of highlight some of the main parts of the schedule, the initial start for the data center is going to be the beginning of 2023. And the total project duration is about 2,421 days. So the completion date will be in April of 2032, which does align with what QTS was saying and their estimated completion date for the data center. The 3 main phases are going to be designing and finalizing. The main phase that's going to take up a bulk of the time is going to be the designing phase, which has 1,480 days. Constructing is going to take 745 days, and then that finalizing phase is going to take 186 days.
Allie?
Sorry, I was on mute. So now we're gonna move on into our risk analysis phase. So this initial graph is a histogram of all of the variation with our final end date. As you can see, this ranges from January in 2032 through November in 2032. So this all falls within that goal end year of 2032, with the most probable end dates being in that April-May area. So that is right on track. And then moving into our decision tree, this is just a snapshot of our overall decision tree. You can see the tree in its entirety in our final report. So we highlighted how their process would change if a permit was to be denied, and then they would have to go through all of the reapplication process. So in order to do this, we had to come up with some key assumptions for the length and size of this decision tree. So we're assuming that they are only reapplying for a permit once, and we only built out the cases where one permit gets denied within the entire process. And for that reapplication, the probability of approval would increase. So if it was originally 90%, 10%, it would become 99%, 1%. And it's very quick and easy to see that the biggest risk in this entire process is getting those permits approved. So then we'll go into our tornado graphs, which break down the key tasks that would add a lot of variability and risk to our project completion. So looking at cost first, we can see that record maintenance and inventory management are both key tasks that if they are completed early, there will be a significant decrease in cost to our project. And if completed late, there will be a significant increase to our overall cost. And then looking at this next tornado graph, you can see also the second two tasks are also inventory management and record maintenance. For these, if completed early, the end date of the project would not have a significant impact. However, if these are completed late, it would add a lot of delays to our end. So because these two tasks have the same amount of variability in both looking at cost and timeline, we plan to put a lot of extra overhead and management and extra resources if needed to make sure that these tasks are completed by their goal end date.
From this analysis, we were able to create a net present value. So we created both a worst case scenario and a best case scenario. Best case just being that all the permits got approved and we didn't have to reapply once. However, for the sake of the presentation, we're just covering the worst case scenario, which is us getting denied for approval. Specifically, this one is the utility permit and then passing all the other permits as well. So with our risk adjusted cost, we found that that was $1,896,000,000. From that, we calculated expecting about 10 years of operation for the data center, that they were going to have an NPV value of about $1,993,000,000. From this, we were able to really kind of just see that there is a large profit here, expecting 10 years of running. And we also have a breakdown, which is on the next slide, of kind of when we break even. So from this, using the NPV numbers, we found that we would break even, so getting more profit than cost of the data center if we operate for a minimum of 5 years. This led us to believe that the situation at hand is a go decision to continue furthering the development of the QTS Fayetteville data center, because we are assuming that minimum they're going to be at least operating for 10 years, which is a conservative number. And since the NPV shows a positive gain after 5 years, we really do believe that the operation should go forthand. Additionally, since the risks that we mentioned before not only are identified, but also manageable. And that was it. Thank you so much.
Fantastic job. Excellent. Very, very complete. I like what you were presenting. I guess I'm curious, what is the source of revenue for the data centers? Do they charge by transaction, by the amount of storage? I mean, who's paying these bills?
So we calculated the revenue from it's not explicit here stated in the presentation, but we found the kilowatts per hour that Atlanta charges to just like use I believe the servers. And then we used our energy capacity and then multiplied that to get like kind of like the available energy that we kind of have to sell. We are assuming that the clients are just like the big clients that work for QTS. So that's like Google, Microsoft, and yes. Does that
So
answer
your
your question?
business model is selling energy, not selling data or storage.
So
Selling the energy to the Googles of the world? Or who do you sell the energy to?
to the Googles of the world.
Okay. So this is more of a power, I guess, power generation type business model as opposed to a data center business model, right?
Yeah, so with QTS being an established company already, we are operating under the assumption that they already have the clients and their set business plan, and this is basically just an addition. So how they are charging currently are the numbers that we use to extend to this basically extension of the data center campuses that they already have, and then use that to find our revenue with towards the end.
Okay. Is there a point in the schedule where you, once you committed to actually the Fayetteville site?
I think that was already done before, like they already chose the site and everything. So we didn't include that in our scope, I think.
So none of the permits could ever derail that site selection, right?
Correct.
Okay. So it's just a question of if a permit fails, you have to resubmit, and it's
Yeah.
just a question of going through the resubmission process.
Yes.
Okay. Because there, I would think, maybe I'm wrong, but I would think that there's a potential that a permit gets denied and there's really no appeal opportunity, right? Let's say you're endangering a native species. Resubmitting the paperwork's not going to change that, right?
Yeah, I think because, again, it's an established company and they've already purchased this land, we are kind of assuming that because they know what they're doing and they know the requirements that they're looking for, that land permit wouldn't be a risk for us.
Okay. But I know I'm adding layers of complexity here, but it's just that it occurs to me that some data centers have been derailed because of native species endangerment. And they literally had to change the site location and site selection as a result. So keep that in mind, I guess, the next time. I mean, it's possible that these permits are more than just paperwork processing. By the way, how much paperwork and processing is there in terms of the total? You have like a 10-year timeline. How much of that 10 years is taken up with paperwork and permits?
A large part of it. I have the
I
breakdown.
just I did the original scheduling without the permits in it, and I'm pretty sure the duration was about 5 years. So then adding in those permits made it up to 9 years. So some of them are very extensive, and they do add a good 3 to 4 years of time to get those permits done.
Right. Or perhaps more, potentially doubling of your time from 5 years to 10. So it's significant. This is unfortunately in this day and age where you're building huge facilities in the middle of, in some cases, lands that are, protected or lands that maybe should be protected. This is the nature of project management. It's not so much managing a team as it is managing a government process, a process where they are approving and you are submitting. And it's a lot of lawyers, regulators, some engineers, and a lot of documentation people. So it's not for everybody. And I guess a project like this, it's kind of hard to get a lot of fulfillment sometimes because it takes 10 years to complete, and the average career is something like 3. So you might have 3 years on this project, which is a third of the project under your belt, and you'll never see the end, or you've never seen the beginning, or you'll have some degree of blind spots in terms of you came in the middle, or you came at the end, or you came at the beginning, and you won't necessarily see it all the way through. In my world of electronics, 18 months, that was a long project. That was a really long project, right? We had 6-month projects.
What was on for of this scope for 2 years, and they would just get switched.
So yeah, you could be at it for 2 years and switched away and not even know what happened to it, or even what the results of your own submissions were, right? You might have submitted something, not even get the results back because you're on to something else. So part of it is, yes, we have a dynamic workforce. I mean, turnover these days is faster than in my time, right? I would say 5 to 7 years was an average career. Today it's closer to 2 to 3, right? Some folks in some parts of the world turn over their job every 18 months. So here's Your folks and your grandparents might have worked their entire careers in one company, 20+ years, right? That's not terribly typical these days. And if you work 20 years at one company, that means you would have a chance to work on 2 of these projects from start to finish. Back to back, assuming they're back to back, right? What did you guys learn from this process? And hopefully you learned something.
Generally so much. I think one, just like the requirements just for an overall just data center, I think the scope was like really insightful. And then I think for me, like the net present value was like something that we like discussed in class before, and I definitely have done it for homework, but I think doing it myself with an actual project really like helped me like understand the concept itself.
So there's a $1.8 billion investment to achieve a $1.5 billion NPV, right?
Mm-hmm.
And that obviously the NPV includes the investment, right?
Yes.
So
Yeah.
there must be tremendous positive cash flow as a result of this data center. And to me, that's pretty, I mean, you're talking $500 million per year is what I'm seeing on this screen, right? That's huge for one data center. So it's
Yeah,
pretty impressive.
our data center is also, it's like one data center, but 16 buildings. So it's a very large project.
Wow.
Yeah,
Very
it's really big.
It's
Size
very
of a small university. We're building a small university here, right?
Yeah.
Okay, very cool, guys. So job well done. Thank you. I think we'll move on to Citadel. Let's give them a round of applause.
Thank you.
Citadel is next. I'll try to keep my comments shorter next time. We get in-person presentations.
Are the presentations on December 2nd also going to be on Zoom?
Some people will be on Zoom, some people will be in person. If you can make it in person, obviously it's better. But otherwise, I'm trying to accommodate people's holiday schedules, right? Take it away.
All right. Okay, great. We are group Reno 2. We created a project plan for one of the data centers within Citadel's large data center campus. Next. So yeah, this is just an image of like the building itself that we have created the project plan for. And just to go over quickly our scope and requirements, we are going to be using 150 megawatts of energy, all renewable. That's enough to power 120 to 150,000 homes. The building itself is 150 million square feet. Tech, including mud, all the buildings that connect to it, is 850,000. So put that into perspective. It's huge. 100% green energy. We're going to be having 27 racks. They're pictured below, each capable of supporting 55 kilowatts of energy and each containing 48 servers. There will be 24/7 security as well. Slide. So just to quickly go over our material and fixed costs, basically most of our costs are kind of split into 2 categories. There is everything we need to physically build this building, and then everything we need to make sure that this building is safe and secure and meets all of the standards and all of the permit requirements. So to go in a little bit deeper with the permitting, with any construction project, there are a lot of general permits that you have to get, including zoning approvals to make sure that the land that you're trying to build on is designated for that intended use. There's environmental permits. You don't want to make sure that you are not disrupting any ecosystems, any water resources, the air quality. You want to make sure that you're not creating too much noise, or that the building itself, think about the hum of all those servers, won't create too much noise and disturb the area around it. You also need to make sure that you have all these electrical permits installed, especially for such a large scale, high voltage systems and backup generators. And also the HVAC system is extensive and very intricate because the cooling system is so integral. Think about how hot this building's going to get. We don't want it to burn down. We also need to make sure that the health department permits come through, and that has to do with the construction site. We want to make sure that our construction workers are being taken care of. We estimated that permitting will cost about $100,000 in total, which is the upper limit of any construction project. But because of the scope of this, we assume that it was going to be that much. So moving on to
Okay.
work resources.
Okay, yeah, so moving away from the permitting, this table right here details the work resources required for this project. We researched industry standard salaries and hourly rates in Nevada to properly allocate these. These rates are slightly above the regional median to account for the complexity of the project and to attract top talent. Salaries are rounded to the nearest $5,000 per year, or $5 per hour, with overtime set at 1.5 times the regular rate. Successful completion of this project depends on efficient coordination between all project teams, and we will need skilled professionals in project management, engineering, construction, and operations. And all of these resources operate off of a base calendar with weekends and major holidays off. So moving away from that and into our project phases, we can see that our project is divided into 6 key phases. In pre-construction, we assign the project team, develop the project plan, select vendors, and handle permitting. Site development includes land preparation, utilities, installation, and foundation work with structural construction, taking over the core structures, cooling system, backup power, and security. And phase 4, for technology integration, we ship, assemble, and install equipment, with us finishing this during commissioning in phase 5. As well as testing power and cooling and conducting inspections. And then finally in launch, we onboard staff, conduct a soft launch, and then transition to full operations. The next slide, the timeline better illustrates this. The project will take a total duration of 1,289 days, or roughly 5 years to complete, and will begin in November 2024. The critical path and key milestones are outlined here. These include essential tasks such as the cooling system installation, equipment shipment, subcontractor installations, and then the IT system integration. Additionally, security inspections and staff onboarding are all vital for the final stages. These tasks must be completed on time to avoid delays and ensure this timely launch of the data center. The target completion date is December 7th, 2029, with full operations beginning immediately after.
All right, so now I kind of want to break down the financials of this. Most of our cost is going right into the actual construction of the building. We're operating at about $1,000 per square foot, and we're at a 1.5 million square foot facility. That number comes from data within Nevada and a different study of data center construction. And we have a very high standard of our data, tier 5, which is fully renewable, tons of redundancy, 100% uptime, 99.999. Anyway, so we're going about $1,000 per square foot, which gets us to 1.5 billion in purely construction costs. Most of that is going to be our electrical servers, backup power, batteries, redundancy, storage, things to support our server racks. Our server racks are going to cost over $200 million to fill up and get to our max capacity of 1.5 megawatts. HVAC mechanical takes about 20%. We have a bunch of cooling, normal building systems, land and shell. That's just our actual construction shell, concrete, steel, all that. And then fit out with meeting rooms, bathrooms, general just building use so we can go day to day. Looking at how we're going to generate revenue here, we're in a critical time for data centers, especially because of AI and the exponential boom that you can see on here. I'm going to minimize this. So from 2021 on to 2023, we're currently looking at 18.6% revenue gains each year after year. And we're looking to take about $200 per kilowatt per month for the standard co-location rates that our consumers end up using. So that 200 kilowatts per month at 150 megawatts ends up getting us about $306 million per year in revenue at 85% utilization. We might not be selling all of our power at once. Using 18.5% growth and our costs, which include 50% revenue reinvestment to keep maintenance, operations, everything, cooling going on, we still end up profiting on the first year, $79 million. And with that revenue growth that is really key to this project, it'll only take about 5 years or so to break even, including that project $1.8 billion cost for construction. Big thing here is timing and making sure that we are growing our industry as long as AI and that industry is growing as well.
All right, so determining your switcher should go ahead and build this data center. We looked at risks not only on ground zero, which we can see here, but we tried to brainstorm and estimate the risks that they will face on day one when the data center is fully operational and 20 years down the line. So in this graph, what we have is a comparison of the severity of the risks at 3 critical time periods throughout this data center's lifespan. So the red at the bottom here are the different types of risks that Citadel or Switch will face when breaking ground. And it has to do with what Katie was talking about with getting permits. So we're fortunate in that Switch already owns the land for the campus. So what they really need to do is making sure they talk with Reno, the municipality, and the state of Nevada to make sure that their building is up to code. Moving over to day one, which we can see here in the yellow, what we can see is the largest impact on this data center's operation is both the natural disasters, and I'm going to also put in energy supply with this. Nevada is a very dry place, and to keep this data center running and fully operational, we need the state-of-the-art cooling system, which requires large amounts of water. So that's what we see both here, as well as in the 20 years down the line, that energy risks and that water issue is not going to go away, but as well as different risks emerge, such as aging equipment when most of our servers within our racks will need to be replaced, as well as different types of cybersecurity risks. And so just, if you could switch to the next slide, please. And so this is just a small snippet of our decision tree for the day one, or for breaking ground and ground zero. This is what, but looking online for different projects within the state of Nevada, we determined how difficult it would be to get these permits and which permits impact other permits that you need to get to make this data center a reality. And so what we determined through the financial analysis and the different risk analysis is that Switch should go ahead and build this data center as one, they already own the land for the campus that they're building upon, as well as the fact that they will break even by year 5 and have large amounts of profit going forward.
Thank you. All right, thank you. So some questions I have. First of all, the permits. I was shocked to see that it was only $100,000. I'm pretty sure you missed a few decimals or something along the way. It probably is in the tens of millions, if not potentially $100 million of permitting costs and fees. You're not just talking about the cost of submitting, the fee you pay to the municipality. It's the preparation time and the effort that sometimes lawyers have to be engaged. So you're talking about some big bucks here, right? So there was a distillery in Evanston that told me they spent, $800,000 or $900,000 just for their permits for the inside the city of Evanston and the state of Illinois. And that was just for one distillery, one building, pretty innocuous type of business. They spent more on that than they spent on the equipment, right? So overall, though, I thought you did a great job. It wasn't clear exactly what your risk-adjusted NPV was. I think you kind of walked around it a little bit. Your tree did tell me that you've estimated the probabilities of success for each leg, but not necessarily how it cascades all the way through the end. So that would be a good thing to understand is, okay, your risk-adjusted NPV is this amount based on all the probabilities and all of the time, value of money, and all of the revenues. It seemed like you had substantial revenues here, right? Similar to the previous team, you had a nice ramp curve. I didn't see that with the previous team. You had a ramp up and kind of, I think you hit a plateau and you stayed there, right? Which I think it kind of passes common sense that it's going to take a while for you to generate the revenue because it's going to take a while to get everything up and running. So I guess I'll turn the question over to you. What did you guys learn from this project? And I guess what surprised you?
I think just the scale of these data centers was surprising. Actually looking into how much support they need to operate is pretty intense. And then Switch is like top of the industry. They're making their own tier. There's tier 4, tier 1 through 4 standard, but tier 5 is like 100% renewable, 2N+1 redundancy in like every system, no downtime ever. And the costs for that are like astronomical.
But isn't that what you pay for in a cloud-based service, right? Otherwise, you'd have a hard disk on your desk, right?
Yeah.
The hard disk on your desk is single point failure, right? Subject to power fluctuations, and all sorts of issues with security. But when you have N+1 or 2N+1 redundancies, all those things get addressed in a systematic way. But that's what you're paying for with
Yeah.
AWS or with Google or any of these services, right?
Yeah, and that we Google, Yahoo, eBay, tons of companies use our services. We don't really specify what. We kind of just send our servers out to probably thousands.
And you're selling the energy like the previous team?
Yeah, so there's co-location, which is like using the racks and the space, and they pay that like $200 per kilowatt per month fee. But then we also charge for electric use of what they end up buying. So it's like they buy the space, and then we also charge them how much they're using of that space.
So it's more or less like a rent plus energy charge.
Yeah, it's like 4.9 cents per kilowatt hour, I think, and then that $200 per kilowatt per month rate as well. So those were our two main revenue generating sources.
So you had one slide that said financial analysis, but it should have been better labeled because it took me a while to figure out. Because to me, finances can be capital, it could be operating expense, and it can be revenue. None of which was labeled on your slide. So and then at the very end, you said it was $1.something billion in capital. Right? I think that's what you said. So you just label it a little bit more clearly so people know whether you're talking about capital, which is a one-time expense, right? Or one-time, I guess, infusion of cash versus operating expense, which is a regular annual thing, versus, let's say, revenue, which is what I kind of thought you were talking about revenue, and then you kind of switched it at the end. It's like, no, this is your capital. Okay, that's fine. But don't keep your audience guessing as to what they think you're saying, right? It should be really clear from start to finish, right? Any other comments, questions? Otherwise, thank you. You kept it within time, so that was perfect. Next up. See who's next up here. All right, we've got Citadel. Sorry, we just finished Citadel. Google Council Bluffs. By the way, I liked how this last team, even the team before, really owned your presentation, meaning there was this sense that you really had a good understanding of it, and you were really in command of the presentation. So that's important to have that sense of confidence that you know what you did, you know what the numbers mean, you know what the backup is. So that's all good, right? So keep it up. Google, you're next.
Good morning, everyone. We are Google Council Bluffs Data Center Project team. I'm excited to start our presentation today by providing an overview of the data center industry and market analysis shaping our project. Next slide, please. Next slide, please.
Sorry, it's not working.
That first click is always, for some reason, there's always a delay.
Give me
There you go. Oh.
few minutes. Sorry. Sorry about.
By the way, feel free to brag about the work you guys have done. This is a lot of work, so you should be proud of it. Share it with interviews, potential players, all sorts of stuff. There you go.
Next slide, please. Next one. Next slide, please. Kara?
I'm sorry, but can someone else share?
Did you try clicking with are you on a laptop?
Yes.
Did you try clicking with your trackpad? There you go.
Oh yeah.
Working now.
Yeah.
The data center industry stands at the crossroads of generative AI, digital infrastructure, and sustainability. North America leads this global expansion, with data center capacity growing by 24.4% in the first quarter of 2024 alone, driven by robust demand from public cloud and AI providers. Thus, sustainability is prioritized by the industry to meet regulatory and consumer expectations. Next slide, please. The key drivers of growth include advancements in cloud computing, AI, and IoT. AI integration not only requires massive computational resources, but also enhances energy efficiency through smart workload and cooling management. Meanwhile, sustainability is not a cornerstone of the industry, with operators adopting renewable energy sources and innovative cooling technology minimize their environmental impact. Next slide, please.
The market is extremely competitive with giants like AWS, Microsoft dominating. At the same time, smaller players like Vantage and H5 data centers target on niche markets, leveraging specialized and flexible solutions. Sustainability and energy sufficiency remain key differentiators, positioning the North American market as a global leader. Emily?
Yeah, we see your schedule slide. Can somebody walk us through it? I think somebody's muted.
Wait, Emily, have you tried changing the audio device? Maybe that's.
Sorry, can you guys hear me now?
Yep, we
I
can
can-
hear you.
Okay. Yeah, sorry about that. Okay, so the project timeline will start on January 2nd, 2025, and will span a total of 4.5 years, estimated to end on April 26, 2029. And the project will take a total of 1,120 working days, assuming a standard working schedule of 40 hours a week, national holidays off, and no overtime. We've also defined 5 key milestones that will, previous slide, that will mark significant markers in our project, such as defining the project scope, which will ensure a smooth operation in the subsequent phases, obtaining all regulatory review completions, which will ensure that we have obtained all the permits to begin execution, the completion of foundation, building shell, and structural reinforcement, which is necessary to begin system installations, system integrated testing completion, which indicates that the data center is ready to begin day-to-day operations. And finally, the final client handover and operational review, which marks the completion of the project. Next slide, please. We've divided our project into 8 stages. First one being project planning and overview, which establishes a solid foundation by defining the project scope, budget, and determining the necessary permits required for our project. Stage 2, site selection and preparation, prepares the site and ensures a smooth transition over to construction. The third stage, infrastructure design and development, is essential as it involves the creation of a detailed plan for power, cooling, and network systems, ensuring that the facility meets the project demands. Stage 4, construction and installation, involves building the facility and installing critical systems. Stage 5, technology integration and equipment deployment, ensures that IT systems and operational software are configured for day-to-day data tasks. Stage 6, testing and commissioning ensures that all systems operate as intended, allowing us to address any risks early on. Stage 7, operations setup and handover, transition to facility to day-to-day operations. And finally, post-project evaluation and optimization provides a framework for continuous improvement and establishing performance monitoring. Next slide, please. Okay, so this is our Gantt chart. We decided to break down each stage into various tasks. Okay, next slide, please. This is the second half. Next slide. Okay, so there's only one critical path, indicating that we have a relatively low sensitivity project. And in addition, various tasks have a higher number of slack days, allowing us to address critical infrastructure tasks while leaving room for flexibility where needed. However, the timeline is comprehensive. While the timeline is comprehensive, we must acknowledge that external factors could affect our progress. So these factors are addressed in our next section in our risk analysis.
Okay, so I'll explain the risk analysis for Google's data center. So this project faces challenges across 4 primary categories, which are environmental, technological, geopolitical, and economic social. Flooding due to proximity to the Missouri River is a significant environmental risk with a medium likelihood and high impact. From a technological standpoint, the facility is a high-value target for cybersecurity threats. Regulatory compliances impacted by evolving privacy and environmental laws possesses geopolitical risk, while workforce availability in this highly specialized sector adds economic and social complexity. To address these risks, we have crafted mitigation plans for each category, which I'll expand on in the next slide. Next slide.
We're gonna have to speed it up. We're down to the last minute or so here, so.
Okay, I'll be quick. So environmental risks include flooding and water resource management, and flood mitigation efforts focus on enhancing levee systems and elevating infrastructure, while water challenges are addressed with air cooling systems and on-site water recycling. In terms of technology, cybersecurity threats are a top priority, and we propose advanced and multi-layer security protocols, rigorous penetration testing, and ongoing staff training. By addressing these risks with proactive measures, we ensure operational resilience and community compliance. Geopolitical risks center on adhering to strict regulations, including VEU program and state-specific investment obligation. To stay compliant, we recommend dedicated teams monitoring policy changes and maintaining open communication with regulators. On economic and social side, workforce availability possesses challenges, and we suggest competitive compensation packages, career development opportunity, and partnership with local institutions to build a sustainable talent pipeline. Next slide, please. And finally, the decision tree provides a structured pathway to manage compliance at local, state, and federal levels. At the local level, zoning and environmental permits are the first steps, and state requirements include Investment Obligation and Consumer Data Protection Act in Iowa. At the federal level, compliance with the VEU program and Clean Water Act is critical.
The construction
Okay,
costs.
we have time to go through all these slides. Sorry, guys. I think you're out of time. Can you just skip to your last slide?
Yes. So the construction will be 1.5 billion. And after construction, it'll be about like $210 million by year. And then for 10-year revenue, so our NPV will exceed the first 5 years of initial cost. Therefore, we recommend to move forward with this project due to its growing market size and demand. Thank you.
Okay, thank you. Nice job. In general, when you have a 7-minute time window, you should budget about a minute per slide. I think you had about 2 or 3 times that. So I think we have to keep, I would say, maximum 10 slides per presentation as a guideline. I thought you had it all there. I'm trying to figure out why your timeline was 5 years to spend over $1 billion and everyone else's is 10. I'm wondering if you factored in all of the regulatory overheads and the time required for permitting. Other than that, I think you had, you did not have any kind of tornado chart per se or any kind of Monte Carlo simulation, but you did have a very, very good risk mitigation plan. So I liked what you did, especially category by category. So every team has its pluses and minuses, but I think you guys did a lot more detail on the costs and I think a lot more detail on the risks. So job well done. Let's move on to quantum loophole. We got only about 8 minutes left. Sorry, quantum loophole. I'll give you the option of presenting next week if you prefer. So you don't feel so time constrained.
We can go now. I think we'll go quickly.
Okay, take it away.
Okay, hi guys. My name is Matt. I'm here with Mark and Junwoo, and we'll be presenting our quantum loophole data center construction project. And we'll be delving into a strategic partnership between Apple and Quantum Loophole. The collaboration addresses Apple's growing need for scalable, secure, and efficient data infrastructure with the surge in data volumes from generative AI and machine learning applications. We hope to provide cutting-edge, energy-efficient infrastructure tailored to Apple's needs, reflecting our shared commitment to renewable energy and reducing the global environmental impact. Selecting the right location was critical to the success of a project at this scale, and we compared 4 U.S. cities to have our data center of Ashburn, Virginia, Seattle, Washington, Portland, Oregon, and Austin, Texas. We included key decision criteria such as job growth projections and unemployment rates and cost of living, as well as some considerations like energy costs, housing affordability, crime rates, and tax environment. We saw that Austin emerges as the optimal choice of these 4. It combines a robust job growth and a reasonable cost of living, as well as a housing market position for growth over the next 10 years. Overall, Austin's energy rates and somewhat favorable tax incentives within Texas provide a favorable economic foundation. So the proposed data center will implement high-density servers and ensure scalable power and cooling solutions spanning 500,000 square feet and sit on around 11.5 acres of land. High-density servers will handle Apple's computing needs for services like iCloud and Apple Intelligence with a modular system that can easily accommodate future hardware demands. Cooling will be optimized using a hot aisle, cool aisle layout with a raised floor to manage airflow in hotspots efficiently. And for AI workloads that are much more difficult, specialized high-density racks will include spot cooling solutions like liquid cooling to support higher performance. Ideally, we'd like to have intelligent monitoring systems to track power usage and temperature so we can ensure that it's an efficient operation. Looking to some power and backup systems, the success of the data center relies heavily on a robust and resilient power infrastructure. So ensuring robust scalable power systems with dual utility feeds is used, implementing UPS systems, emergency shutdowns, and EMI management to protect the equipment and operations. Focusing on environmental controls, PDUs, and monitoring to systems to maintain safe and efficient power distribution, and integrating backup generators and maintaining the UPS suites to ensure power continuity occurs during the potential outages and future expansion. And then finally, just some key safety considerations and design considerations. We're going to be implementing, some key fire detection systems like VESDA for early warnings. Our fire suppression is going to be using pre-action sprinklers and clean agents for environmental safety. For fire safety, we're going to have regular testing, system maintenance, and emergency procedure training. Our design is going to be a single-story windowless structure with large columns for minimal environmental impact. Hopefully, we'll have access to dual electrical grids. And for cooling, we're going to be maintaining specifically 70 to 74 degrees Fahrenheit with 45 to 50% humidity, similar to other data centers with the aforementioned hot cooling aisles for consistency overall. I'll pass to Mark for a bit more of the scheduling side.
Thanks, Matt. So looking at the timeline and critical path, the project spans approximately 226 weeks or about 4.33 years. Our early tasks such as construction equipment procurement and the foundation phase are crucial for setting the stage for the rest of the project. These tasks are tightly interconnected with zoning and permit approvals, as well as utility connections, making delays in one area potentially disruptive to the overall project timeline. For example, site approval, which takes 4.5 months, is pivotal for initiating the major construction phases. Sustainability features and cybersecurity compliances are also critical milestones, ensuring that the project aligns with Apple's environmental and operational standards. Looking at the resources and task breakdown, the project cost is approximately $453.8 million, with significant expenses including the IT equipment at $125 million, land acquisition at $80 million, and $130 million allocated for renewable energy systems like solar panels and batteries. Labor tasks such as construction demand over 15,000 crew hours, emphasizing the importance of efficient workforce coordination. Early construction tasks like the exoskeleton framework and HVAC ducting are major cost drivers and must align with the procurement schedules to prevent bottlenecks and ensure smooth progress. Finally, turning over to our Monte Carlo analysis. Uncertainty was modeled using 1,000 simulations with a triangular distribution. The costs are tightly clustered around $453.85 million, with 80% confidence that these costs will not exceed $453.88 million, demonstrating really just robust budget control. The histogram duration shows a mean of 212.6 weeks, slightly shorter than the deterministic estimate of 226 weeks, which shows that we can manage variability. And the sensitivity analysis highlights utility connections, transformers, and construction foundations as having the greatest impact on our cost and schedule. These tasks require careful monitoring and coordination as they are linked to downstream dependencies. And by proactively managing these high sensitivity areas, the project can minimize delays and cost overruns and maintain a steady trajectory towards project completion. Now I'll hand it over to Jimu to talk about our risks.
Yeah, so 3 of the big global risks that we identified include cybersecurity, natural disasters, and climate change. So we're collecting a significant amount of data for users given the generative AI purpose of the data center. So we want to be conscious about taking safe measures. Given Texas can be prone to high temperatures, we acknowledge that heat waves and flooding may occur. And lastly, for climate change may alter temperatures and potentially cause natural disasters. So this may lead to increased cooling demands and future operational costs. So now going into the decision tree, 3 things I want to point out are the zoning permit, which confirms land use aligns with zoning laws. And the brunt of this cost is in regards to land acquisition. The site plan reviews the project layout and infrastructure, and the brunt of this cost is base building construction and other mechanical components of the design. And lastly, electrical permits, which regulates electrical installations and safety. And the brunt of this cost is the electrical equipment and power. Now, like I talked about for the zoning permit, the $80 million is for the land acquisition. And if you go into the next slide, after each permit is approved, which the cybersecurity compliance is the last one, the data center actually becomes operational. And then from that, we were able to include the profit to get the risk-adjusted NPV, which is present on the next slide. So the annual profit that we're expecting is around $143 million. And by integrating all of our risks and our costs, we're able to get a risk-adjusted NPV of around $231 million. And given an IRR of 30% and a payback period of 3.13 years, we ultimately decided that we're going to proceed with the data center, given that it's financially viable. And for an exit strategy, if challenges arise, options such as reassessing the financial model, exploring partnerships or joint ventures with other tech companies, or even adjusting our operational plans to minimize loss would be the best step moving forward. And given the operational viability, the data center ensures future growth, energy efficiency, and long-term sustainability with advanced cooling and powering systems. So the timeline of 4.33 years is very achievable. Thank you very much.
Very nice job. So I liked your scope up front. You were very detailed in your scope analysis, probably more detailed than any other team I saw. I liked your risk, at least from the Monte Carlo perspective and from the tornado chart. I think you guys have made the most out of both of those. Your summary at the end was excellent. I guess one area I didn't see too much was specific risk mitigations. Maybe you skipped over that, or maybe I just missed it. Other than that, it's very complete. You owned it. You had a really good sense of what you were talking about. You were able to do it very crisply. I think you did it in about 7 or 8 minutes, so I give you a lot of credit for that. So in other words, I think all the teams did a great job today. I don't think any of you will be disappointed with your grades. If you are, let me know, but I doubt if you will. I hope that you got something out of this assignment, and I guess I'll see half of you, at least. I'd like to see all of you next week, but I'm going to hear from half of you in terms of the drug discovery. Very different types of projects. What they have in common is they're both quite long in duration. They're quite valuable to the company. Almost all of them will be worth at least about in the order of $1 billion each, right? And all of them have a huge degree of complexity to them, just spanning anywhere from 7 to 10 years. I was surprised that the last 2 teams only had 4-year or 5-year projects. I guess I'm going to have to look at it in more detail to understand why was the first team 10 years and everyone else was closer to 4 or 5. So something's awry here. Maybe it's just the scope of the project and the starting point that I need to understand better. But other than that, look, everyone did a great job. Comments from the people in the audience here, the people that were listening to them all. What do you think? Yeah, very good. Very crisp. I like the fact that you literally had a slide at the end that says risk-adjusted NPV equals this, right? If all you get is one slide in front of your CEO or in front of your COO, that's the slide you're going to show them, right? The bottom line is we recommend a go. This is the reason for it. These are the numbers behind it. If you want more detail, we got 14 slides we can go through, right? That's what they want to see. The ability to take your presentation and either do it in 20 minutes or do it in 60 seconds. That's the key to being able to succeed in today's corporate world. All too often, in fact, when I was at Motorola, we had a CEO who came in and said, I don't want any PowerPoint slides. Put away your PowerPoint slides. Just tell me what you want to tell me and tell it to me in less than 5 minutes. I'm told that Tesla, Elon Musk, wants all of his presentations in under 30 seconds. So there's no time for PowerPoint. You literally have to own it, know it, deliver it in as summarized a fashion as you can, down to maybe 4 or 5 bullets. Boom, 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 right? All right, have a good weekend, have a good holiday, have a good Thanksgiving, and see you on Monday. Luckily, I don't think anyone's outside pushing us out, so that's a good sign.